Electronics is a dynamic and ever-evolving field, essential for designing, developing, and maintaining electronic devices and systems. Professionals in electronics are responsible for creating circuits, testing devices, troubleshooting malfunctions, and implementing new technologies in various industries, including consumer electronics, telecommunications, automation, and robotics. Interviews for electronics roles assess technical knowledge, analytical skills, and the ability to apply concepts to practical problems. In this video, we will explore common electronics interview questions, along with sample answers and practical tips. This guide helps candidates structure responses, demonstrate technical expertise, and showcase problem-solving capabilities. Well-prepared answers not only highlight your knowledge, but also reflect your ability to communicate complex concepts clearly and effectively, which is crucial for succeeding in the interview. Understanding the electronics role. An electronics professional is expected to have a solid foundation in circuit design, electronic components, signal processing, and troubleshooting techniques. Employers look for candidates who can design, test, and maintain electronic systems while staying updated with emerging technologies. The role may involve working with microcontrollers, sensors, power electronics, communication systems, or automation equipment. Preparing for interviews requires demonstrating both theoretical understanding and practical experience with electronics projects, simulations, and hands-on applications. Question 1. Can you explain your experience in electronics? Here's how you can answer. I have experience working with both analog and digital circuits, designing and testing PCBs, and programming microcontrollers, such as Arduino and Raspberry Pi. I have also worked on projects involving power electronics, sensors, and signal processing. These experiences have helped me develop practical skills in circuit design, troubleshooting, and component selection. Tip: highlight specific projects, components, and tools to demonstrate hands-on experience. Question 2. What is the difference between analog and digital circuits? Here's how you can answer. Analog circuits process continuous signals, while digital circuits handle discrete signals represented by binary values. Analog circuits are often used in audio, radio, and sensor systems, whereas digital circuits are used in computers, microcontrollers, and digital communication systems. Understanding both types is important for designing integrated electronic systems. Tip: show understanding of both types of circuits and their applications. Question 3. Can you explain Ohm's law and its significance? Here's how you can answer. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. Mathematically, it is I equal VR. Ohm's law is fundamental in circuit design and analysis, helping determine the values of voltage, current, and resistance required for proper functioning. Tip: explain both the formula and its practical relevance to real-world circuits. Question 4. How do you troubleshoot an electronic circuit? Here's how you can answer. I troubleshoot by first understanding the circuit diagram and identifying potential points of failure. I then use tools like a multimeter, oscilloscope, or signal generator to measure voltage, current, and waveforms. I systematically test components, check connections, and isolate the faulty section. Once identified, I replace or repair the component and retest the circuit to ensure proper functionality. Tip: emphasize systematic problem solving and use of measurement tools. Question 5. What is a microcontroller and how have you used one? Here's how you can answer. A microcontroller is a compact integrated circuit designed to perform specific tasks by controlling devices and processes. I have used microcontrollers such as Arduino and PIC in projects like temperature monitoring systems, automated lighting, and robotics. I programmed these devices using C++ and integrated sensors and actuators to achieve the desired functionality. Tip: highlight practical applications and programming experience with microcontrollers. Question 6. What are the differences between an NPN and a PNP transistor? Here's how you can answer. An NPN transistor allows current to flow from the collector to the emitter when a positive voltage is applied to the base, while a PNP transistor allows current to flow from the emitter to the collector when the base is negative relative to the emitter. NPN transistors are commonly used in switching and amplification circuits, while PNP transistors are used in complementary configurations or specific biasing circuits. Tip: show understanding of transistor types, operation, and practical applications. Question 7. How do you design a PCB? Here's how you can answer. I design a PCB by first creating a schematic diagram using design software like Eagle or KiCad. I then lay out the components, ensuring proper spacing, trace width, and signal routing. I also consider power distribution, grounding, and thermal management. After finalizing the design, I generate Gerber files for fabrication and perform testing once the PCB is assembled. Tip: highlight attention to detail, use of software tools, and testing practices. Question 8. What is the importance of signal processing in electronics? Here's how you can answer. Signal processing is essential for extracting, analyzing, and modifying signals to improve accuracy, clarity, and performance. It is used in communication systems, audio and video processing, and sensor data analysis. Understanding digital and analog signal processing techniques allows me to design circuits that handle data efficiently and reduce noise or interference. Tip: show both theoretical knowledge and practical relevance in applications. Question 9. How do you stay updated with advancements in electronics? Here's how you can answer. I follow industry journals, attend webinars, participate in online courses, and engage in electronics forums and communities. I also work on personal projects to apply new concepts and experiment with emerging technologies. Staying updated helps me integrate modern solutions into my work and remain competitive in the field. Tip: emphasize continuous learning and practical application of new knowledge. Question 10. Why should we hire you as an electronics professional? Here's how you can answer. You should hire me because I have a solid foundation in electronic theory, practical experience with analog and digital circuits, and proficiency with design and testing tools. I am a problem solver who can troubleshoot complex circuits, work independently or in teams, and adapt to new technologies. My combination of skills, experience, and dedication makes me a strong candidate for this role. Tip: summarize technical expertise, experience, and alignment with the company's needs confidently. Final thoughts. Electronics interviews assess technical knowledge, problem-solving skills, hands-on experience, and the ability to apply concepts to real-world scenarios. Preparing structured answers, sharing examples from past projects, and demonstrating practical skills can help candidates stand out. Employers value professionals who are technically proficient, analytical, and adaptable to evolving technologies. By presenting examples of circuit design, troubleshooting, PCB development, and signal processing, candidates can make a strong impression. Emphasizing attention to detail, continuous learning, and the ability to apply theoretical knowledge practically ensures that you are seen as a capable and reliable electronics professional ready to contribute effectively to projects and innovation.